Okay, in this video I'm going to go over the test that I just returned about global heating and circulation, climate, global weather patterns and wind patterns. So there were two parts to the test. Well, there was initially one test, and then we broke it down into two parts because we redid some parts. So the first thing I'm going to do is go over the parts I graded on the initial test. So I did grade the first three problems. For the first problem, it was some climate graphs showing temperature for two locations. And then for each location, it was to say whether or not it's an inland or a coastal location, high latitude or low latitude. So for City A, the signs that indicate that this is a coastal and low latitude location are that there really isn't much seasonal change. So it looks like the amount of seasonal change we see for places like Los Angeles, which is around 30 degrees, or Cairo, which is around 30 degrees as well. So there's a little bit of seasonal change, but really not a high latitude amount. It's closer to the equator than to the North Pole. Also, we see that there is really like the coolest temperatures in the 70s, around the 80s, 60s, and the highest temperature is really not that high. Around the 80s for the average, 85, around up into the 90s, around 90 degrees for the highs. So that's really not that hot. So that's a pretty good sign that this is coastal and not inland where we'd see larger temperature extremes. For location B, we see that there's these very big extreme temperature differences, which indicates that this is further up, closer to the poles, North Pole. And down in the winter here, we've got average temperatures around 20 degrees, down into the 10s for lows. And in the summer, we got pretty warm temperatures, not super hot, not into the hundreds, like we might see at an inland, lower latitude location. Still a little bit cooler at night, but pretty warm. And so this looks pretty similar to a place like Chicago, a little bit higher of a latitude and inland. So we would say high latitude, inland. If it was low latitude and inland, we really wouldn't see these colder winter temperatures. It would be these extremes, getting pretty hot, but hotter temperatures in the summer and warmer temperatures in the winter. So again, for City A, coastal, low latitude. For City B, inland, higher latitude. I also graded number 3. Wind blows from areas of, remember, high pressure to low pressure. So we think about where we have high pressure, we have air forcing itself downwards more so onto the surface of Earth, and that's going to mean it's pushing the air that's at the surface of Earth out of the way. Okay? Where we have low pressure, the general mass movement of air is upwards, so maybe air is warming and rising, but it's really less dense air that's getting pushed up. So winds form as the air moves down from higher pressure and up at lower pressure. I also graded number 8 for this test. That's the one where you're looking at the climate graphs and the atlas and choosing two locations, comparing them and saying why those differences exist. What I'm going to do now is I'm just going to talk through a couple of them so you have a few examples. You can always use your own example and modify it and improve it. A lot of students really just needed to explain why the differences existed that did exist. So thinking about things like, is it inland or is it coastal? Is it high latitude or is it low latitude? Is it in a place where prevailing winds blow from over the ocean or over land? So is it does it seem like it's in a rain shadow? Is it in the mountains? Is it at a lower elevation? Really thinking about all these different factors that might cause the differences that you see on the graphs. Now, when I say the graphs, what I'm referring to is that was on page 14 and 15. And if you come in and need to borrow a book, you can come in during my office hours and borrow one of these books. So we can talk, a couple people talked about comparing Cairo, Egypt, and Tehran, Iran. So those are two good comparisons, and I'll take a moment now to compare them. When we look at their graphs, we see that they're both pretty dry, but Tehran gets more rain. It also has more extreme temperature differences. They both show some seasonal temperature differences, meaning they're not right down on the equator, but they're a little bit higher. In fact, both are around 30 degrees north, and we'll look at that on the map in a moment here. For the amount of rainfall they get, Cairo gets much less than Tehran. They both don't get a lot of rain, but Cairo gets much less. So when we look at where they're located, Cairo is at the top of Africa in Arabia, and Tehran is a little bit further north and is much more inland. And so the fact that Tehran is much more inland really explains those big differences seen in their temperature. Cairo being right on the coast has more of kind of a coastal Mediterranean condition going on here. Really being on the coast is has a big influence. Now, Tehran is going to get some winter weather coming in as westerlies blow across the Mediterranean into the mountains here. Tehran's actually up into the mountains, so they get a little bit of effect of some rainfall as the weather moves, again with the westerlies, moving across their mountains. Cairo is very close to this 30 degrees. This is 30 degrees north. It's a very dry part of the world because you have high pressure, so you don't get a lot of rain there. You have dry air sinking at that point. Also, the prevailing winds are going to move. Prevailing winds move further south this way, and so Cairo is really not in the area where it gets much of prevailing winds. When it does, they tend to blow across this way, across the continent. Not that you would need to have known that. The key thing here is that really seeing that Cairo is more coastal, Tehran is more inland. Also, Tehran is up in the mountains. So if you looked at the physical map for Tehran, you would see that it's up in the mountains. Another couple locations you can compare is Chicago and Los Angeles. So when we compare Chicago and Los Angeles, we see that they have similar high temperatures, but Los Angeles has much more moderate winters, while Chicago gets very cold winters. LA gets a lot of rainfall in the winter, and Chicago gets a lot, kind of like a moderate amount of rainfall throughout the year. So looking at those two locations might help explain some of those things. So what factors might cause those differences? First off, we see right off the bat that Chicago is at a higher elevation, so that explains some of those seasonal differences, the much colder winters. Also, Chicago is inland, so it has more of a continental weather effect. In the winter, it gets much colder being inland as this continental air mass gets cold. Los Angeles, being on the coast, has very moderate winters, as most of their weather is influenced by the Pacific Ocean. So when we think about the rainfall, the fact that Los Angeles is really wet in the winter, what we can think about is that as storms move through, they move in off the ocean. Okay? The westerlies are bringing storms in off the ocean. While for Chicago, storms are coming in over land, or from over the continent here, spiraling down through the lakes. And so a little less moisture in the winter, and in the summer Chicago gets that more, a lot of this moisture coming up from the maritime air masses off the coast here that kind of push up into the U.S. So really what you can focus on for those two is the difference in location of coastal and maritime versus continental, the differences in the wintertime weather of Los Angeles getting water from over the ocean versus Chicago getting cold moisture from the Canada and storms coming inland. And I could do one more comparison. A lot of people kind of compared, let's see here, I saw a lot of people compare Jakarta, Indonesia. Okay, and we could actually compare that to, let's make a comparison between Jakarta and a pretty extreme difference. How about Barrow, Alaska? So for Barrow, we see these extreme seasonal differences because Barrow is way up high, okay, very far north, while in Jakarta we see very little seasonal difference in temperature because Jakarta is right around the equator. We also see for Barrow that it's actually very dry, cold and dry, because it's in that northern area where cold air can't hold a lot of water, so it's pretty dry up there. Throughout the year, in the summer it's a little bit wetter as the temperatures start to warm up, but in the winter it's pretty dry. The prevailing winds for Barrow are the polar easterlies, so you got winds blowing off of this area here. Now if you think about that being like, oh, well that's water, well in the winter it all freezes, so it's not really, you can think of it as an ice cap as opposed to being water, so that kind of makes it so that it's not so much a maritime condition. In the summer there's a bit of a maritime condition, but really in the winter not so much. When we think about Jakarta being on the coast, okay, that helps moderate the temperatures a little bit, making it so that the temperatures aren't quite as hot, but it is very humid and very wet. Because on the equator, remember, we have warm air rising, and as air rises, whatever water is inside of that air starts to condense and precipitate. So we get lots of rainfall happening as Jakarta goes through the seasons. So Jakarta generally has a wet season and a dry season, but there still is definitely some rain all year round. So there are some possible examples. Remember that the key thing for getting credit for this one is that you explain factors of climate and factors for temperature and precipitation. Okay, so when we talk about factors, we talk about those things like location, maritime versus continental. So you need to be addressing those when you talk about what happens and try to touch on something that affects temperature and something that affects precipitation for the locations and making them unique. So the other part of the test, we had the retake parts. And for the first part of that, you had to kind of show some air movement around the globe. So I'll talk about that real quick. The first part said mark the location of high and low pressure. So remember that at the equator, it's the warmest place around the globe in general. And so you have warm air rising at the equator because we have the most direct sunlight, lots of warmth. So the warm air rises, warms up, warm air rises. Now, what happens is air is flowing in to replace that. that warm air moves and sinks at 30 degrees. So at 30 degrees we have high pressure. Okay, so, and then at 60 degrees, we have another spot where, well actually let me jump to 90 degrees at the very top. So here it's the coldest place, so we have cold air sinking. And that cold air sinks and moves down the surface of Earth, and as it gets closer to the equator, it starts to warm. Well, around 60 degrees, it warms enough that it starts to rise. As cold air is pushing further, creates what's called a convection cell occurring there. And that happens all around the surface of Earth. Now, if it's rising here, it's going to be rising on the other side. And here you have the air that sank around 30 degrees pushing up the surface of Earth. So we get these convection cells. That wasn't one of the parts of the questions, but kind of like an added bonus. So these convection cells, and they actually wrap all the way around the globe. Okay, so they're not just in one spot, but they're occurring all the way around the globe. They're going up into the air and sinking down, up into the air and sinking down. Okay, all the way around the globe. Now, remember, air moves from places of high pressure to low pressure. But here's the deal. Because of the Coriolis effect, as the Earth spins, as that air moves, it kind of gets set off course. And what ends up happening is, we talked about it spinning in these directions. Okay? And so this is, because of the Coriolis effect, we get the winds moving in these different directions. And what we call them is, we call these ones the trade winds. We call these ones the westerlies because they come from the west. And then we call these ones, here I'll kind of draw an arrow pointing to them. We call these ones the polar because they're up north, easterlies. Sorry, there's a little bit of sunlight. Let me try to block that. So the next questions, you guys would choose one of them to answer, and there were 4 different options. The first one said, explain that global winds don't all move straight up and down from pole to equator, but instead move from different directions and between different specific latitudes. In other words, explain what you drew in problems 1, 2, 3. Your answer should include latitude, convection cells, pressure belts, and Coriolis effect. So I'll look back at this and talk about that, because it says kind of think about why it looks like this. So first off, the reason that we have different pressure belts at different latitudes is because the surface of Earth is warmed differently depending on the different latitudes. It's warmed the most at the equator and the least at the North Pole. And so that makes an area of low pressure along the equator and an area of high pressure at the pole. Now, that warm air rising then cools, condenses, and sinks, and scientists find when we observe the Earth that it happens around 30 degrees. I actually don't know the specifics of why it happens there, and I'm not sure if scientists really know. You could look that up on your own and see. But essentially, warm air is rising and then sinking, and where it sinks, you can think about the air pushing down. It's cooler. That's going to be high pressure. So if I was standing on the surface of Earth here, air would be pushing down on me, so it's going to be more pressure. And so that pushing air is pushing air out of the way and back to these low pressure locations. Here at the North Pole, very cold, cold air sinking, pushing down. Okay, think about the convection tank we saw with the water and we had the ice. Sorry, that's supposed to say ice. And we had the candle, the heat here, and hot water rose and then sank. Okay, same sort of thing happening on the surface of Earth. Okay, convection. It's that transfer of heat. So we have air sinking and then rising where it's a little bit warmer. And so this creates what are called convection cells. Convection cells are really just the movement of air between places of high pressure and low pressure. Okay, that's it. Now, as the air is moving within the convection cell along the surface of Earth, that means that winds are blowing in general across the surface of Earth. And the winds blow from the place of high pressure to low pressure. So they blow down from 30 to 0, they blow up from 30 to 60, and down from 90 to 60. And as they move, they don't go straight up and down. So we would expect them just to go straight up and down. But because Earth is spinning, it ends up kind of setting them off course a little bit. And so that makes the winds blow sideways as they go. So the trade winds blow sideways from the east to the west, westerlies from the west to the east, and the polar easterlies from the North Pole east down to 60 degrees. Let me just leave that there if you think about it for a second. And now let's jump to the one on the back. So this problem says, explain the type of global wind causing a nor'easter to travel up the east coast. Also explain why it brings lots of snow to the northeast U.S., while a similar storm off the Pacific coast brings lots of rain to the northwest USA. Your answer should mention specific global wind involved in the Coriolis effect. So here's the U.S. Ta-da. So as these storms form, okay, so we think about a couple storms forming. We had a warm-up we did about this as well, okay. Storms wrap around low pressure spots, and so you have a storm spinning because of the Coriolis effect. Now the storm's spinning because of the Coriolis effect, and also because of the prevailing winds, they move in specific directions. So the westerlies move up and across the U.S., and so storms that form down here get pushed up and across the U.S. in a southwest and northeast movement from the west to the east because of the westerlies. So this storm ends up moving in this direction. Let me get a highlighter to help kind of show it. So this storm, as it's spinning, it's also moving in this direction. Okay? Now, think about as the storm gets up north where it's colder. So now let's say this storm has shifted. It's now up here. So now, again, the air is spinning around this low pressure point. Okay, this storm spins, and it spins counterclockwise. Okay? Well, as that air spins around, as it's off the shore, but it picks up cold air and then comes whipping down over from up north over Canada where it's cold. And well, what happens to water in the air when it's cold? It freezes and turns into snow or ice and falls to ground. And so that's why you get lots of snow with a nor'easter happening over here. Now, on the west coast, we might get storms that are also spinning around. So this air is spinning around that storm, around that low pressure point. But this time, okay, and again the storm is moving up because of the westerlies. It's moving up the coast and inland. But this time, as it gets up here, okay, the prevailing winds spinning around aren't coming from up north, they're coming from down south. And so it's not as cold, it's not as frozen, so we get some of that wet weather that's not as cold. It's still cold because it's winter and it's cold, but it's not frozen precipitation. Okay, finally, there was a problem that talked about the image below shows a path hurricanes generally follow. Explain which global winds are involved in moving the hurricane along these paths and why you think those winds are involved. So if I look here, this is showing the path the hurricanes move. Well, this is near the equator. In between the equator and 30 degrees, between those two locations, well, these are going to be the trade winds. Okay, so the storm is following within the track of the trade winds. As that storm starts to head north, all of a sudden it jumps over to where it's within the westerlies, because above 30 degrees we have the westerlies. So now that storm is moving with the westerlies. So the fact that it moves in this sort of pattern of across and then up, going across and then up, is because it's in the trade winds, and then later it ends up in the westerlies. And that really explains which winds are involved in moving hurricanes up to the U.S. and along the East Coast. So that pretty much covers the entire test. You can always come see me during office hours. I can explain more in detail and help you out if you need some clarification. Thanks so much.